everyone, I am Ayan, and today we will be solving an Intermediate Maths Olympiad question. So, if you want to, you can have a go at solving it. You'll need to pause the video if you want to do this. Now, let's go through it. The squares on each side of a right angle scalene triangle are constructed, and 3 further line segments are drawn from the corners of the squares to create a hexagon as shown. The squares on these 3 further line segments are then constructed. So there are 3 squares that are constructed here, here, and here, and they are outside the hexagon. Right, so we already have a good amount of information. So we have 6 squares, 3 of which share a side with the right angle scalene triangle. The combined area of the 2 equal size squares is 2018. Right, so 2 of the 6 squares have the same area, and their areas add up to 2018. And they are asking for the total area of the 6 squares. When doing the question during the test, you would aim to solve it in around 25 to 30 minutes. So time isn't really an issue. In the test, there are 6 questions, but you should only really aim to do a maximum of 4 of them. And you have 2 hours to do this. So now let's try and solve it. Let the right angle scalene triangle have sides of length A, B, and C. Then the areas of the squares on each side have areas as shown, so A squared, B squared, and C squared. Also, the outer square has area C squared, because its side length is the hypotenuse of another right angle scalene triangle that is congruent to the original one. So why is it congruent? Because this is A and this is B, and the same here. So this is A and this is B. So then their hypotenuse must also be C. So then this is also C squared, because it's a square. And we need to find the side lengths of the other 2 outer squares. So these 2. Because we have been asked to find the total area of the 6 squares. Further, in the question, they have given that 2c squared is 2018. Therefore, c squared is 1009, because these 2 are the 2 squares with the same area. So now we basically have c as a square root of 1009. So now we have a triangle with 2 sides and an angle in between known. So the sides are B and C. And cos of theta is B divided by C, the adjacent divided by the hypotenuse. So cos of 180 minus theta is negative cos theta, which is negative B by C. So if you're struggling with this concept, you can think of the cosine wave as the distance, as a point's distance from the y-axis as it travels around the circle. So like over here, where my pointer is right now, it is at its peak distance from the y-axis. And over here, it is on the y-axis, so it will go down to 0, so pi by 2 radians. At pi by 2 radians, it will be 0, and like that. Okay, and now going back, we need to find the length of the third side, because we know these 2, and we need to find this. And over here, we know these 2, and we need to find this. So how do we find the third side of a triangle, giving 2 sides and an angle? This is where the cosine rule comes in. So, the cosine rule is basically like the Pythagoras theorem generalized for all triangles. It relates the lengths of a triangle given an angle. Now let's prove it. So here we have a triangle with side lengths A, B, and C. We dropped a perpendicular line from the vertex, and this line is E. So then we have two right angle triangles, one with sides A, E, and D, and the other with sides E, B, and F. Cos of theta is once again the adjacent divided by the hypotenuse. This is D divided by A. So we get this, and then we can rewrite D as A cos theta. Sine theta is the opposite divided by the hypotenuse, so E divided by A. And then we get E is A sine theta. And now looking at this triangle, we get that, oh no, not this triangle, looking at this length, we get that F is C minus D, because D plus F is equal to C. Now let's look at this triangle, and we get that B squared is E squared plus F squared. But we already have E squared, so it's A squared sine squared theta, and F squared is all of this because of this. So then, and this is the cosine rule. So the cosine rule is once again basically the Pythagoras theorem. So if we plug in 90, then B will become the hypotenuse, so, and then this will all cancel out. So we'll basically get the Pythagoras theorem with B, the hypotenuse. Now we can use the cosine rule. D squared is B squared plus C squared minus 2BC cos of 180 minus theta. And so simplifying, we get 3B squared plus C squared is equal to D squared. So the area of this square over here is 3B squared plus C squared. And similarly, the area of this square over here is 3A squared plus C squared. Hence, the sum of all of the 6 squares is 4A squared plus 4B squared plus 4C squared. Because we have 3A squared here, 1A squared here, 3B squared here, and 1B squared here, and 2C squared here, and 2C squared here, and we have this, and A squared plus B squared is equal to C squared, just using the Pythagoras theorem for this triangle right here. So then we get that the area of the 6 squares is 8 times 1009. See if you can quickly do that math before the animation does. So it's 8072. I hope you enjoyed working through this problem with me. So thank you for watching. Goodbye.